Hello everyone. Today we will continue our discussion on chapter number 2, polynomials. This is the third part of our discussion on this topic, and in this session we will discuss exercise 2.2, question number 1 and 2. Question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Roman number 1, 2, 3, 4, 5, 6. Out of these 6, let us discuss Roman number 3 and the Roman number 5. In Roman number 3, it is given as 6x square minus 3 minus 7x, and Roman number 5, t square minus 15. Then question number 2. In question number 2, we have to form a quadratic polynomial with the given pairs of numbers as sum and the product of the zeros. So let's continue to find the solutions of these two questions. Okay, so let us discuss the solutions of the above mentioned questions. Let us see. Yes, in this slide I have given the solution of question number 1, Roman number 3. What is the question of that? We have to find the zeros of the polynomials, and at the same time we have to verify the relationship between zeros and the coefficients of the polynomial. It is seen that the given polynomial p of x is equal to 6x square minus 3 minus 7x. Here this is not in the standard form, so let us write this in the standard form first. So to write the standard form first, we have to interchange second and the third term. So in this next step, I have written here 6x square minus 7x minus 3. It is in the form of ax square plus bx plus c. And when we compare the given polynomial with the general quadratic polynomial, we see that a is equal to 6, b is equal to minus 7, and c is equal to minus 3. As we did in class 9, so let us split up the middle term. For this we have to find two numbers whose subtraction gives us 7. Because the multiplication of a and the c gives us minus 18, and the sum gives us minus 7. So let us write two numbers, minus 9 and plus 2. Minus 7x is written as minus 9x plus 2x, because these two numbers satisfies the condition. From the first and second terms, 3x is common. After taking common, we observe that the leftover part is 2x minus 3. Again, from the third and the fourth one is common, so I have written here 2x minus 3. From these two, again 2x minus 3 is common, and after taking this common, the remaining factor will become 3x plus 1. So the two factors of the given quadratic polynomial are 3x plus 1 and 2x minus 3. Now from this we have to find the solution. So from this we have to find the zeros. If I take the first one, the first factor, that is 3x plus 1 is equal to 0, then this implies that 3x is equal to minus 1. Therefore x come out as minus 1 by 3. Similarly, from the second factor, putting 0, then we have got the answer again as 3 by 2. So the zeros of the given polynomial are minus 1 by 3 and 3 by 2. After finding the zeros, now let us verify the relation of zeros with the coefficients. So what will be the sum of the zeros? Sum is equal to minus 1 by 3 and 3 by 2, because they are the zeros. And taking LCM of 3 and the 2, it come out as 6. And if 6 is divided by 3, then we are getting the answer as 2. 2 multiplying with minus 1. Like that, the numerator come out as minus 2 plus 9. And further simplification gives 7 by 6. And again minus b by a. Minus b, what is our b? Our b is minus 7. and our a is 6. So let us put their values here, and again simplifying, we have got the answer is 7 by 6. Therefore we can say that sum is equal to sum of the zeros equal to minus b by a. Again, for the second part, let us go for the product. Product is equal to minus 1 by 3 multiplied by 3 by 2. 3 cancels here, and finally we got the answer is minus 1 by 2. And c by a, answer is c is minus 3, so minus 3 divided by 6. Again, after calculation, we have got the answer is minus 1 by 2. Here again we see that product is equal to c by a. It means that the relation between the zeros and the coefficients of the polynomials is verified this way. Again, let us take up Roman number 5 or question number 1 again. The given polynomial is in the variable t, so let us use p of t. Here p of t is given as t square minus 15. 15 is the square root of 15. So t square minus square root of 15 whole square. Applying algebraic formula, a square minus b square, it come out as a plus b and a minus b. Again, let us put both these factors 0. First, let us put for the first factor t plus square root of 15 is equal to 0, and therefore t becomes minus root over 15 by transposing root over 15 to the right side. Similarly, when we calculate the value for t from the second, again we got the answer is root over 15, that is square root of 15. Therefore, we can say that the zeros are square root of minus square root of 15 and the square root of 15. Now let us verify the relationship between the zeros and the coefficients of the polynomial t square minus 15. If we write this in the general form, then we will put in the form of t square plus 0 into t minus 15. Okay, so here let us compare with the general form, and we have got the answer as, what is the answer of a? If we compare the coefficient of t square and x square, it is a and the 1, isn't it? So we are writing as a is equal to 1. Similarly, if we compare the coefficients of t and the x, then it will be b is equal to 0, and likewise c equal to minus 15. So these are the values of a, b and c. Now sum is equal to minus root over 15 plus root over 15, it is 0. Also, calculation using b and the a, that is calculation using coefficients, is equal to minus 0 by 1 is equal to 0. Therefore, sum of the zeros is equal to minus b by a. Again, for the product of zeros, minus root over 15 into root over 15, that is minus 15, and calculation using coefficients, again c by a, is equal to minus 15 by 1 is equal to minus 15. Therefore, we can say that product of zeros equal to c by a. So like this, we can prove or verify the relationship between the zeros and the coefficients of the quadratic polynomial. Next, let's go for the solution of question number 2, where we have to find any quadratic polynomial whose sum is square root of 2 and the product is 1 by 3. For this, any quadratic polynomial in x is p of x is equal to k multiplied by x square minus sum of the zeros into x plus product. Here sum is square root of 2, so I have written here square root of 2, and product is 1 by 3, where k is not equal to 0. After simplifying, taking LCM, then we have got the numerator 3x square minus 3 square root of 2x plus 1. Here let us make the denominator 1, okay, by taking a value of k. By taking different values of k, you will get different quadratic polynomials, but the sum and the product will remain the same. Therefore, by taking k is equal to 3, a quadratic polynomial is 3x square minus 3 square root of 2x plus 1. Again, in the same way, let us find for Roman number 5, question number 2. Sum is minus 1 by 4 and product is 1 by 4. So any quadratic polynomial is k times x square plus minus sum of the zeros into x plus product. So minus 1 by 4 will become plus, so we have written here like this. And after taking LCM, then numerator will become 4x square plus x plus 1 divided by 4. So for a particular quadratic polynomial, let us take k is equal to 4 to make the denominator 1. So and the quadratic polynomial is 4x square plus x plus 1. Next, let us discuss division of polynomials. Here, the relation among dividend, divisor, quotient, and remainder remains the same. Dividend is equal to divisor into quotient plus remainder. In this topic, we will discuss division algorithm. What is division algorithm? If p of x and g of x are two polynomials with g of x is not 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x multiplied by q of x plus r of x, where r of x is equal to 0, or the degree of r of x should be less than degree of g of x. It means that in this algorithm we have to continue the division process till the degree of the remainder is less than the degree of the divisor. Here g of x is the divisor, q of x is the quotient, and the r of x is the remainder, and the p of x is the dividend. Let us learn this division algorithm of polynomials by taking this example. Divide 2x square plus 3x plus 1 by x plus 2. Here the dividend is a quadratic polynomial and the divisor is a linear polynomial. Now let's see the algorithm here. Yes, in this slide 2x square plus 3x plus y is the dividend and the x plus 2 is the divisor. So to start writing for the quotient, first we have to divide the highest power term of the dividend by the highest power term of the divisor. So I have divided 2x square by x. 2x square is the highest power term of the dividend and x is the highest power term of the divisor. So after cancelling x from numerator and denominator, the answer comes out as 2x. So we have to write this 2x as the first term of the quotient. Now this 2x should multiply with the two terms of the divisor, and the answer come out as 2x square plus 4x. Then after writing this, we have to go for the process of division. Then plus changes to the minus because we have to subtract these two terms from the dividend, and this 4 becomes minus 4x and the 2 becomes minus 2x square. So the first terms cancel each other, and from the second we have got as minus x. Then after this the term one which is left over in the dividend is taken down for the next step. Then again here in this term the highest power term is x minus x, and the highest power term of the divisor is x. So if minus x is divided by x, then the answer is minus 1 again. So the next term of the quotient is minus 1. When we multiply minus 1 with x plus 2, then we got the answer is minus x minus 2. Then again by normal division procedure, then the sign of 2 changes is positive and the x changes is again positive, and 1 plus 2 becomes 3 here, 3. Here we have to stop the division process because this is the remainder. Why is it remainder? Because the degree of these 3 is less than the degree of the divisor x plus 2. Finally, we can write cosine is twice x minus 1 and the remainder is 3. Let us verify the relation among the four. Dividend is equal to divisor into quotient plus remainder. Divisor is x plus 2 and quotient is twice x minus 1 and remainder is 3. So when we open the bracket and then we multiply and got the answer as 2x square minus x plus 4x minus 2 plus 3, and finally it is 2x square plus 3x plus 1, which is nothing, which is the dividend of the given polynomial. Today's home assignment, you solved the remaining problems of question number 1 and 2 of exercise 2.2. Then in number 3 you find a quadratic polynomial having zeros 2 plus minus root over 3. That is, the zeros are 2 plus square root of 3 and 2 minus square root of 3. And in question number 4 you solve Roman number 1 and 2 of question number 1 exercise 2.3. So these are a few problems for home assignment for today. Thank you all. Okay, have a very nice day ahead.